Liking this video will help this channel to grow. So please go ahead and give this video a like. In this section, we're looking at listing outcomes and sample space diagrams. Please remember to like and comment in order to help to boost the YouTube algorithm to share this channel with others. So guys, let's begin by looking at listing outcomes. Listing outcomes in probability involves systematically identifying all results of an event, which is essential for calculating probabilities accurately. Now, to ensure that we list all the possible outcomes, we can use the product rule for counting. Now, when we talk about the product rule for counting, this is a method of finding the total number of combinations of selecting items from a set or different number of sets. It could be one or more sets. So that means from the get-go, we would know how many listings we are expected to get once we use the product rule. And the word product here means that we are multiplying. So in the first instance, we're going to be listing some outcomes, all possible outcomes of given events. However, I'm going to show you first of all how you can use the product rule for counting to find out how many options are possible. So if I look at this question using the product rule for counting, a coach is designing a new rugby strip. She can choose from 5 different pairs of socks. So I'm going to underline 5 different pairs of socks is a choice, 6 different pairs of shorts, and 14 different jerseys. We want to find out when the team is going out to play, how many different possible combinations could you have based on the items. So simply to find out how many different ways we could combine these items for the team to look different each time, what we need to do is to multiply the possibilities. So for the socks, there are 5 possibilities multiplied by, for the shorts, there is 6 possibilities, and for the jerseys, there is 14 possibilities. Now, by multiplying them all together, so 5 times 6 times 14, believe it or not, guys, there is 420 different combinations that you can get from these items. Now, if you understand the product rule for counting, it makes it very much easier for you when you buy a new phone or a new gadget and you're going to make a password. Your understanding of the product rule for counting can make you make a password that's almost impossible for anyone at all to break into your device. So imagine this was a phone, guys. You could have 420 different possibilities using these combinations that you could use to make a password. Beautiful. Now that we know how to calculate the different outcomes, how many possibilities, we're going to do some questions now. Now for the first one, we don't necessarily need to use the product rule for counting, but I'll use it in another question. So here we are told that a shop sells ice creams. Each ice cream has 2 scoops. Again, so we underline that here. So 2 scoops for each ice cream. The possible flavors are vanilla, strawberry, chocolate, and mint. So we're told the 2 scoops can be the same flavor, or they could be different flavors as well. We are asked here to list all the possible options for the 2 scoops. Now, whenever we are going to be listing, it's very important to follow a particular order so that we do not forget some of the events that we need to be listing. So for example, I'm going to start off first of all. So to make it easier, I'm going to put V SCM for the combinations. So I'm looking for the first option to get from my table, and the combined version of that would be from the numbered letters I've written down here. So remember, we can take two flavors. I'm going to take a vanilla and a vanilla. I could take vanilla. So let's go now. This is how you do it in an orderly way. I could also have taken vanilla with strawberry, so VS. I could also have taken vanilla with chocolate. I could take vanilla with mint. So I'm just using the letters there to represent them. So now I've done all my possibilities where I start with vanilla. Now I'm going to move on to starting with strawberries. So I could take strawberry and a strawberry. Or I could take strawberry and chocolate. Or I could take strawberry and mint. So I write that down, strawberry and mint. Finish with strawberry, I'm now going for chocolate. I could also take chocolate and a chocolate, or I could take chocolate and mint. Now guys, you may say, why should we not take like chocolate with strawberry? Remember, we have already strawberry with chocolate, so it's pretty much the same combination. Now I go for my mint. I could take mint and another mint. I could also have taken, so if you notice here, mint, but I have exhausted all possibilities with mint already because I've combined chocolate with milk. So if I count now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possibilities. So that is 10 possibilities altogether. Very important. We do not put a chocolate with a mint, then a mint with a chocolate, because that combination was already seen. So we do not replicate them. Very important to note there. So in this option, we've got 10 possibilities we could get from just those 4 flavors. Beautiful. So we're going to look at now at another example. So here we're told that children on a school trip must choose an item of fruit, drink, and a sandwich. The fruits on offer are pear and grapes. So pear and grapes. We've got the drinks are water. So water, juice, or squash. So I'm just going to be using letters for those. So sandwiches are either cheese or tuna. We're asked to write a list of all the possible outcomes. So first of all, I'm going to use the product rule of counting to see how many options should I have altogether. So because for fruits there are 2 possibilities, there are 3 options for the drink and 2 options for the sandwiches. If I multiply them all together, I will know how much should I have on my list. So I've got 3 times by 2 is giving me 12. So I'm expecting to get 12 possible combinations. So what I'm going to do, I'm going to start off with my fruit using a pear and all possible combination with the pear. When I'm finished with that, then I can go for the grapes and get all possibilities with the grapes. So let's go. So I could take a pear. So first option, a pear with water and cheese. Or I could get a pear with juice and cheese, or I could get a pear with squash and cheese. So now that we looked at all the cheese, we're now going to do that again, but this time with tuna. So I could get a pear with water and tuna. I could get a pear with juice and tuna. I could get a pear with squash and tuna as well. So we've listed all the possibilities starting with a pear. Now we're going for the other fruit, which is a grape. So I could get grape, water, and cheese. I could get grape, juice, and cheese. I could get grape with squash and cheese. You can see it's the same replica of starting with a pear. So therefore, I could now get grape, water, and tuna, or it could be grape, juice, and tuna, or it could be grape, squash with tuna. Now that I've listed my possibilities, I can now quickly check, did I get 12 or not? So I've got 1, 2, 3, 4, 5, 6 on either side. 6 times 2 is 12. So I know I've listed all my possibilities. Beautiful. So now we are moving from listing outcomes to looking at a sample space diagram. So a sample space is a list or a diagram that displays all possible outcomes of two combined events to help us calculate probabilities. So this is what our diagram look like. Imagine throwing two die and asked to make a sample space diagram. We know that the possibilities on the die is 1 to 6, so we make our first die, label 1 to 6 as a horizontal line. And for the next one, it's going to be vertical. And then we will calculate. We've got to pay attention. Are we adding the numbers together or are we multiplying? So just the numbers in the grid would be our sample space. Now we're going to do a question on the sample space. So we're told here that Jade rolls a 6-sided die twice. So 2 times. That tells us what our table should look like. And finds the product. So again, product means to multiply. So she finds the product of the results. We're asked to complete a sample space diagram to show all the possible outcomes. And then we've got some questions to answer from the sample space diagram. So I've pre-drawn my table. So I'm multiplying my results. Remember, I need to multiply to get my results. So first one, 1 times 1 is 1. 1 times 2, 2. 1 times 3, 3. We can see this is just our one-time table. Hence, we will have 4, 5, and 6. We go for 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. Again, this is our 2 times table. So we're going up in 2. So 10, 12. So once we see our pattern, we can just carry on the pattern. 1 times 3 is 3. 3 times 2 is 6. Then times by 3, 9. So 12. 3 times 5, 15, and then 18. Next, we go for 4. 4 times 1 is 4. Then we've got 8. 4 times 3 is 12. 4, 4, 16. 4 times 5 is 20. And 4 times 6 is 24. 5 ones 5, then 10, 15, 20, 25, 30. Then we go for 6, then 12. 6 times 3, 18. 6 times 4, 24, and then 6 5, 30, and 6 6, 36. So once we see the pattern, carry on. We're finished completing our sample space diagram. Now we're asked to answer some questions from the diagram. So here in part A, we are asked to calculate the probability of getting a prime number. Now guys, remember our first prime number is 2, the only even number that's prime. So I'm going to go onto my table, my sample space, and I'm going to check all the prime numbers here. So I'm going to put a tick. So 2 is prime, 3 is prime, 5 is prime. 2 in the next row, no prime numbers are other than 2 are even. There's 3 for a prime number in the third row and only 3. In the next row, there is no prime numbers at all. Then we've got 5 here. Then we look, no other prime numbers in the 2 coming rows. So let's count 1, 2, 3, 4, 5, 6. So we got 6 prime numbers out of the total of the sample space is a 6 by 6. 6 times 6 is 36. This can now be simplified. 6 into itself goes once and into 36 goes 6 times. So therefore 1 6. We go for part B. Part B asks us to calculate the probability of a square number. So I'm going to put a star beside the square numbers this time. First square number is 1, since 1 times 1 is 1. Then we've got 4. Then we've got another 4 here. Then in the next row we got 9 to be a square number. In the next row we got another 4 there. And then we've got 16. Check the next rows. There is 36 in the next one, at the last one, and also 25. So if we count our stars, 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 options out of my sample space of 36. Again, can simplify. 4 goes into 8 2 times, and 4 goes into 36 9 times. The answer then is 2 9s. Next question asks us to find a number greater than 20. So remember, greater than 20 is not included. So I've got 1 here, which is 24, 2, 3, 4, 5, 6 options. So that is 636 again, which we saw was simplified to be 1/6. Finally, we've got a cube number. So we know cube number is when you multiply a number by itself 3 times. So 1 is our first cube number, and then 8 is our next cube number. So we got 1 and 8. We got another 8 here. We have no other cube number, so there are 3 possibilities of 36. 3 into itself goes once, and into 36 goes 12. So the final answer is 1/12. Beautiful. You can play the video again just to see how to complete your sample space and how to answer your questions from that. Now we're going to look at the final question, and then we will just wrap this lesson up. Beautiful. So we're told that Rebecca has 2 bags containing counters. Each counter is labeled with a number. Now guys, you could be asked to draw your own sample space diagram, and this is what you would do. So observing bag A, I've got 1, 3, 4, and 5 as my options. You can see here, we've labeled that along the side of the diagram, 1, 3, 4, and 5. In bag B, there are 3 options, 1, 5, and a 7. Now, Rebecca picks a counter at random from bag A and then a counter at random from bag B. We're asked to complete the table to show all the outcomes. Now, this one is different. We're not multiplying or adding. We are just taking 1 from each. So we can see here, if I get a 1, a 1, a 5, a 5, I could now get a 1, a 7. I got a 3 and a 1. I could get a 3 and a 5. I could get a 3 and a 7. I could get a 4 and a 1. I could get a 4 and a 5. I could get a 4 and a 7. I could get a 5 and a 1. I could get 5 and a 5. I could get a 5 and a 7. So careful of what your question asks you to do, and make sure you do that. Now we're finished completing it. We're asked, what is the probability Rebecca picks a 1 from bag A and a 7. So we're looking for 1, 7. So if you look here on our diagram, we got one option where there's 1 and 7. So therefore, it's just going to be, out of our sample space diagram, this time we got 4 by 3, which is 12 options. So the answer then is just going to be 1/12 for that. Beautiful. Last question before we wrap up. What is the probability that Rebecca picks counters with the same number? So we're looking for 1 and a 1. So we got a 1, 1 here. Then the only other option is a 5, 5. So there are 2 options of the sample space, which is 12. Simplifying, we get 1/6. Absolutely brilliant. So this is how we do our listing of our outcomes using our product rule for counting, and also using our sample space diagram to answer questions of probability. Now guys, this is now our 4th lesson in our series, so therefore we got 1 more to go. So make sure that you have watched lesson 1 to 3 and now watching 4. Also make sure that you share it, give this video a thumbs up, and also interact with our TikTok shorts as well. And we also have other shorts on YouTube as well. Make sure that you're engaging with all those beautiful exam questions. And guys, until the next time, thank you so much for watching.